All right, so today we're going to talk about perpendicular lines. And so we already know a lot of things about perpendicular lines, so let's just kind of refresh on some of the things we already do know. So this first problem gives us two lines. It gives us the equations and asks us to find the point of intersection. So one method that we can use is substitution. They're both set equal to y right now, so I can set them equal to each other by substituting essentially this negative 2x plus 1 for the y in this equation. And then I have to solve. Now for me, algebraically, I would prefer to have no fractions while I'm solving this. So I'm going to go ahead and multiply everything in this equation by 2. The reason being is that that's going to get rid of this 1/2. And so I'm going to be able to solve this more easily. But in order to do that, I do have to multiply everything by 2. So this becomes negative 4x plus 2 equals x minus 28. Now I have an equation free from fractions, and I can finish solving by subtracting the x to the other side, subtracting the 2 to the other side, and then dividing by the negative 5. Once I've gotten that x is 6, I need to figure out what y is. I can substitute it into either equation, but there's one equation here that is going to be easier to substitute it in because there's no fractions. So I'm going to choose that. And now I get negative 12 plus 1, so my y is negative 11. So the intersection is a point, so I do want to write my final answer as an ordered pair like this. Now, it says confirm your answer by graphing on your calculator, so I actually already did that because it can be kind of slow to do. So when you do, you put it into y equals. You might have to adjust your window because it is below the typical window from negative 10 to 10. So I did adjust my window here at negative 15 for y, and then that way I can see that intersection, and I do see that the intersection is at 6, negative 11, like we found. All right, then it asks us, are the lines perpendicular, and to give a reason for your answer. So whenever I'm trying to determine if lines are perpendicular on a coordinate grid, I want to compare the slopes. So the first slope was negative 2, and the second slope was 1/2. And so when I compare those, I'm thinking, oh, those are opposite reciprocals. So because they are opposite reciprocal slopes, they must be perpendicular. Now, I do always want to make sure that I have a good claim and evidence and reasoning. So when I look at this, here's my claim. Yes, they're perpendicular. Here's my evidence, right? Those are my slopes. And then here's my reasoning. Okay, so next we're going to talk about some constructions with perpendicular lines. This actually is going to be very familiar to you, but we're going to talk through it. So the first thing is how to make a perpendicular line from some external point. So they're going to give us this line and this point, and our goal is to make a perpendicular line through point R to this line that they've given us. So the first thing we're going to do is we're going to take our compass and we're going to make sure that the length of the compass is longer than the distance from just R to the line, because our goal is to take this compass and to swing it on both sides so that it intersects in two places with this line that we have. So that creates for us a point P and a point Q. What we're going to do now, the easiest way to do it is you're going to just keep your compass the same length. Now, if you change the length of the compass here, it's fine, as long as then you keep it the same when you do it from P and from Q. But the easiest thing is just don't change the size of your compass. So now what I'm going to do is I'm going to take that length and then I'm going to put my metal point at P, and I'm going to swing to create an arc. And then I'm going to put the metal point at Q and swing to create another arc. And what happens is where those two arcs intersect, we're going to connect that intersection to our point with a straight edge, as always. And we're going to label it with a nice right angle mark because we've just created a perpendicular line through point R. Now, what if we would like to make a perpendicular line, but this time we want to make it through a point that's already on the line? So this time, like last time we were saying, okay, we want to make this perpendicular through this point that's not on the line. Now we're going to say, how do we do this through this point that's already on the line? So I'm going to go ahead, and the first thing I'm going to do is I'm going to set my compass to some length, and I'm going to swing it on both sides of the line so that it intersects the line at two places. So I'm not going to change my compass width. So I'm going to draw that arc right here, swing it to the other side, and draw that arc right there. Notice that's actually almost the same step that we did first, right? We wanted a compass, our arc set by the compass to intersect the line in two places. So now this created a P and a Q. And what we're going to do next is we're going to keep that compass and we're going to make it a little bit longer. So we need to make sure it's at least past the point that we're trying to draw a line through. So notice how it's wider from P beyond K. And we are going to put the metal point on P, and we're going to swing it to make an arc. And then we're going to put the metal point on point Q and do the same thing. And now where those arcs intersect, we now can create that point that is going to connect to point K, and that creates our right angle. All right, so those QR codes are there if you need to go back and watch it again and go step by step, but you can practice, make sure that you can create those two constructions on your paper. Now, the next thing that we're going to do is we are going to go ahead and talk about some example problems. I'm actually going to have you skip question 4, and this is a question you might decide to come back to later, but we're going to start with question 5 here. So with question 5, it tells us that we have some line LM and some line QM, and they're perpendicular at this point M. So I need to draw this, right? So I have these two perpendicular lines, and so I can draw them as best as I can, and they're perpendicular at point M, right? So I'm going to draw my right angles. And I didn't quite label yet the LM. So L is going to be on one line, right? So that I've now created a line LM. And then Q is going to go on the other line somewhere. It doesn't matter where I put it. And that creates this line QM. So now I have my intersecting lines. They're perpendicular. And then it tells me that the angle LMQ has a measure of x squared minus 31. So there's my measure. Now, if I went ahead and labeled these two as perpendicular, what I see is, oh, we actually already know the measure of this angle. The measure of this angle is 90 degrees. We also know that this expression represents 90 degrees. So we can just set up an equation. X squared minus 31 must equal 90 degrees. Now, I'm going to solve this, and you might be thinking, oh, I need a factor box here, but you don't, because there's no x term here. I can just add 31 to the other side, and I get 121. And then to get rid of the square and the x square, I can just square root both sides, and that gives me plus or minus 11. Now, a lot of times when we get that positive and negative, both answers don't work because it's a distance. But in this case, plugging a positive or a negative value for x in for this expression will both give us this positive 90 degrees, so they both work as x values. All right, and now we have one more problem we're going to do, and we're going to talk some more about claim evidence reasoning here. So the first thing I have to do is I have to draw this. So it says I have two lines that are intersecting at point V. So I'm just going to draw my two lines first as best I can. And they're intersecting at point V, so here's my point V. And the two lines are RS. So I'm going to put my R and my S. And my other two lines are going to be my T and my U. So I've now created this diagram, and now I just need to label these. It says the measure of angle RVU is 4x, And the measure of angle RVT is 114 minus x. So we want to figure out if these two lines are perpendicular. In order to answer that question, I need to set up an equation and solve for x so that I can see if they're perpendicular, I should get that these are each 90 degrees. But I don't know if they're perpendicular, so I'm just going to set up an equation that I know is true. I know that together, this angle right here and this angle right here are making a straight angle. So that means they're adding to make 180 degrees. So my equation is going to be 4x plus 114 minus x equals 180 degrees. And so now I can solve algebraically to see what is x. So I get 3x plus 114 is equal to 180. Then I subtract 114 from both sides, and I get 3x is equal to 66. And then I divide by 3 on both sides, and I get x is equal to 22. Now, because I set up an equation that I know is always true, regardless of whether these are perpendicular, I know for sure that x must be 22. And now I can use that to answer the question, are these perpendicular? So if I substitute in 22 degrees here, 114 minus 22, that gives me 92 degrees. And 4 times 22 gives me 88 degrees. So now I can answer this question, are they perpendicular? Well, I did not get 90-degree angles here, so they are not perpendicular. So I need to write a sentence to justify this. So my first sentence, the first part of my sentence is going to be my claim. So my claim is no RS, line RS and line TU are not perpendicular. So I now have, this is my claim, this is all my evidence. I need to connect these two with my reasoning. So what's my reasoning? My reasoning is that I know what a perpendicular set of lines do. Perpendicular lines intersect at right angles. And because the measure of angle RVU is 88 degrees, not 90, these lines are not intersecting at right angles. So this is my reasoning. So what I want you to notice about this is my claim right here. They're not perpendicular. Here's my evidence, all the work I did to calculate what x is and what those angles are. And then my reasoning, notice how it connects the two, right? My claim was that they're not perpendicular. My evidence was that they weren't 90 degrees. I need to explain why these values made me say that they're not perpendicular. Well, the best way to explain that is to explain what perpendicular lines are. Perpendicular lines intersect at right angles. And so I know these aren't right angles because they're not 90 degrees. So that reasoning part has to connect your claim to your evidence and explain why did your evidence make you make the claim that you did. Okay. All right, this last question 7, you are going to give a try on your own. Your goal is to create, using your construction techniques, a perpendicular line, so not like I'm doing right now, but you're trying to create a perpendicular line through both, this way and this way. So like this and like this. Now, you're not going to eyeball it like I just did. You're going to use your construction techniques to do that.